You are done thinking about this? Okay, well, let's divide this into two here and think about the first one first. How many ways can 6 people be arranged in a row? If you have 6 people and you want to know how many ways you can arrange all of them, it's just 6 factorial, or 6 times 5, because there's you could pick any one of the 6 people to be first, then any one of the 5 remaining people, and so on, right? All the way down to the last person. Okay, till you get to the last person, it has to be 1 there. So whatever 6 factorial is, what is 6 factorial? 720? All right. 6 factorial, 720. 720 different ways for those 6 people. Can you guys... this one is a little bit harder. You have to think about it. Depending on what your first thought was. Actually, your comment was a good one first, which was... What was your comment right off the bat? Are you counting? Yeah, are you counting? Does and I heard a few other people saying it does. Vancouver, Calgary, is that the same as Calgary, Vancouver? I guess if you really were doing this, you'd have to decide: are we counting Vancouver versus Calgary, like in Calgary? Is that the same as or different than Calgary versus Vancouver? If you're counting them as the same, then we don't know how to do that yet. But that's okay. Maybe, actually, since it's only 2, maybe you can think about it, right? Pretend that these are different. If you count these as different, then you're asking for permutations of 2 from how many? Right? You're choosing 2 teams from 30. If you care about the order, that's what permutations is, right? If you care about the order. Later on after lunch, we're going to look at combinations, which is where you don't care about the order. Then these would be the same, right? If you're talking about combinations. For what we have done before, when you look at permutations, if you're choosing 2 from 30, if you were choosing all 30 of them, it would be 30 factorial. Okay? If you were choosing, if you're choosing all 30, how many arrangements of all 30 teams? It's 30 factorial. But you don't care about all the teams you don't pick. So you get it indirectly by dividing by the arrangements of the ones you do not pick. That's the permutations formula. Okay? It's 30 factorial over 30 minus 2 factorial. The bottom are the ones you do not choose. Those are the ones not chosen. Because you don't care about the order of the ones you're not choosing, right? If you're deciding how many orders of these 2 teams there are, switching the ones you don't pick doesn't change that. Has somebody done that on their calculator, or can you do that by hand? How do you do that without using the factorial button on your calculator?
30.
Yeah, 30 times 29 times 28 factorial, and then this 28 factorial. At that point, factorial just means all the ones below it, right? All the whole numbers below it multiplied. So if you kind of expand the one that's a larger number, you can get down to that point. All right? And so it's whatever 30 times 29 is. You could do this just from the fundamental counting principle and just think, I have to pick one of the teams to be first, right? You didn't actually need the lecture on permutations for this, because you could just use the fundamental counting principle and say, I can pick any one of the 30 to be the away team, or to be this team, right? And then I can pick any one of the 29 to be the second team and multiply those 2. Okay? Either one of those 2 gives you the same thing. What's your comment?
Does that mean that Vancouver, Calgary, and Calgary versus Vancouver
Are different. The way we're doing this is counting those as different things. Okay? If you want to say I want to count these as the same, in this particular case, it's easy because for any 2 teams you pick, how many different arrangements are there? No, for any 2 teams. For any pair of teams, there's only 2 ways, right? Home and away, or away and home. Like, you can switch them. So what does this number give you, by the way? 30 times 29, what is that? 870? 870? That's how many there are if you count. There's 870 possible different matchups if you count home and away as different. If you wanted to know, counting those the same, like how many different pairs of teams could you make, it's actually going to be that divided by 2, right? Because for every pair there's 2, so it would be that divided by 2, 485. Okay? There's 485 different ways you can pair up the teams if you don't care about who's home and who's away. That's what we're going to do, what we're going to look at afterwards, after lunch. It's not a hard concept here because if you took this number, you divide by the number of permutations of the ones you do choose. All right? Probably, if my math is correct here, which it obviously isn't. 435, thank you. 435. I just over-exaggerated my 3. Okay, can you find your section 6.3 in there, and we'll talk about that?